Good day everyone, we are Hypernova and in this video we are going to walk you through a simple but powerful Python program that helps you design a basic solar PV system. This tool takes you from the solar panel specifications all the way to inverter planning, string configuration, cable length estimation, and even breaker sizing.
So let's go ahead and run the program. We will explain the inputs and outputs step by step. So first step, entering the solar panel specification. We'll start by entering the specification from our solar panel datasheet. First up is the panel wattage, that how much power one panel can produce under the standard condition. Let's go with 550 watts, which is quite typical and high efficiency panel. Next is the open circuit voltage or VOC. This is the highest voltage that panel will produce when it's not connected to a load. It's important for inverter safety limits. From the datasheet, we'll use 49 volts. Then we enter the ISC or short circuit current. This tells us the peak current the panel can push, and we use it later for sizing our DC breakers. I'll input 13.5 amperes. Finally, we input the physical dimension of the panel. This helped the program figure out how many panels can fit on the available space. I'll enter 2.2 meters from the length and 1.5 meters for the width.
For step 2, entering roof area. Now we input the total area available for installation. Maybe it's a roof or ground-mounted space. I'll enter 100 square meters. Using this in the panel size, the program calculates how many panels can fit. In the output, you'll see it now gives us the number of panels that fit and total solar capacity in kilowatts. So far, it's handled the physical layout planning. For step 3, we have inverter specifications. This next part is all about the inverter. We start with the maximum DC voltage it can accept. It has to be higher than the total voltage of solar string. For my datasheet, I'll enter 1000 volts. Then we input how much AC power each inverter can output. I'll go with 5000 watts or 5 kilowatts, which is a common scale inverter size. Next up are the MPPTs. These are like the solar sink input ports on the inverter. Let's say we have 2 MPPTs and each one can handle 2 strings. So that's 4 string total for inverter.
4. Distance to panels DC cable. Here we input the estimated distance between the inverter and the panels. The program uses this to calculate the total DC cable length required. We multiply it by 2 since we account for both positive and negative runs. I enter 15 meters. For output, once we hit enter the program display, how many panels should go into the string, how many total string we need, how many inverters are required, and how many string each inverter will carry. It also let us know if manual adjustment is needed. For example, if the string account per inverter exceeds the input limit based on MPPTs. For step 5, breaker sizing DC and AC. Enter nominal AC output current per inverter A. This value comes straight from your inverter datasheet. It is the regular output current the inverter will deliver. I enter 21.7. For output, now the program calculates 2 types of breaker. One is DC breaker, size based on the short circuit current of the panels. 2. AC breakers, size based on the inverter output current multiplied by safety factors. It even rounds the sizes to the nearest 50A step, which is typical for selecting commercial breaker sizes.
So with just a few key inputs, all from the standard datasheet and layout planning, this program helps us estimate almost everything we need to get started on a solar PV design. From system size and layout, the string configuration, inverter count and cabling, and even the breaker specs is really handy too. So that's all. Thank you.